Well, we can get started here. I appreciate everyone attending today. And, if you're coming in late, not a big deal. After the webinar here, we will send out a copy so folks can forward it to other folks, watch it on demand, whatever the case might be. This is our first webinar for the 2023 webinar series. So my name is Patrick Dunn. I'm the Director of Demand Generation here at Rapid Robotics. Really excited this year. I think a lot of what we're going to be talking about is really impacting not only our customers and partners, but pretty much everybody across the board. So really looking forward to your participation. Feel free to ask questions. Steve Barsanti, who's our Director of Customer Operations, is going to be kind of walking through our how to hire a robot in 5 easy steps. Steve, I think, is probably the most knowledgeable when it comes to what we're going to be talking about today. He's probably an expert. I still learn from him pretty much almost every minute, so I'm a little embarrassed about my lack of knowledge, but Steve is the expert here. So Steve, I'm going to let you take it from here. And again, as you have questions, feel free to put them in either chat or the questions, and we'll get to them here at the end of the presentation. Steve, take it away.
Yeah, so first and foremost, I will correct one thing, is that I am definitely not the most knowledgeable. It's the team beneath me that is constantly teaching me new things on a daily basis. And what I'm going to highlight today is really most of their work, and giving everyone an idea of the process that we go through from start to finish in a deployment. So to quickly introduce myself, I'm Steve Barsanti. I'm the Director of Customer Operations. I've been with Rapid for the 3 years we've been in business. I was one of the day one employees. And so I've really been able to see this entire end-to-end deployment process shape up from where we thought we were going on day one to where we are today, and all of the learnings in between. And so what I'm going to do today is share with you some of those learnings and some of a look behind the curtain as to what happens when we go on site with our customer, all the way to initially find opportunities, all the way through to actually having robots on the floor doing the work. And this will give everyone a sense of how you can all better prepare for automation on your floor, and then also get a good understanding of what we do on the back end to really make this a successful process for Rapid and for our customers. So to start, one of the big challenges that American manufacturers have today is the complexity, the cost, and really the flexibility of the automation solutions that are out there. And we started Rapid to address these challenges and make it very, very easy for our customers to be able to put robots on the floor. And a big part of how we do that is on the operational side, right? We are looking at things in a totally different light. For Rapid to be successful, we need to be able to deploy very quickly, cost effectively, and at scale, right? And so when we are assessing opportunities and we are deploying to those opportunities, those are the driving forces behind what we do. And really, that doesn't just benefit Rapid, it benefits customers as well, because it allows us to provide solutions that have not been previously easy for companies to provide. And so we basically transfer our efficiencies to our customers via the pricing model that we're able to put forward. So again, what you're going to see today in this webinar is, like I said, a look behind the curtain. I'm going to go through the various phases of our deployment, all the way from the pre-sales through post-sales and support, and just give everyone a sense of what we are doing here at Rapid. Whoop, 1 second. Okay, So our process is broken down into 5 simple steps. We start with a feasibility assessment where we're understanding what are the requirements of this task, what do we need to really focus on. From there, we start with a conceptual design and basically design what is this going to look like when it's actually on the floor. After the automation design, we do a prototyping and testing. This is a very quick gut check on our concept and our initial design to ensure that everything that we're assuming is actually going to be accurate. And then from there, we basically prepare for that on-site deployment. So again, we're doing a lot of testing, and all of this happens on our floor, so we're not interrupting your day-to-day production. We're doing that on our factory floor, and then we basically button it all up, put it on a truck, head out to your factory, and spend as little amount of time on your floor as possible to get that into production. Now, once it's in production, we stay for a period of time to observe, to make sure things are running smooth before we hand it off to our support team. Our support team then takes our cloud software and remote monitoring tools and ensures that we don't have to go back on site at all. And if we do, that we are doing so only when necessary and with advanced understanding of the problems that we're going to see when we get on site, so that we can very quickly drive to resolution. So this is a very high level look at what our process is. And then what I'm going to do the rest of this presentation is dive into some of the details on every one of these steps, showing everyone the tools that we use, and as much of the secret sauce as I'm able to share. So it all kind of starts with the feasibility assessment. And quite honestly, I see this as one of the most important parts of the process because, again, like I said, Rapid's successful when we are able to deploy fast and at scale and robust deployments that are not prone to a lot of support issues. So that all starts with task selection. And in order for us to be successful, to provide our customers with an experience that is productive for them as well, we need to make sure that we are taking on tasks that we are very highly confident we will be able to achieve. And so we have a very strict, rigorous task assessment process that we go through to ensure that we're not signing up for something that we can't do. And as a matter of fact, to date, we have never taken on a task that we weren't actually able to implement when it came down to it. And that is due to a lot of tools that we've put in place. Our sales team is the first line of defense, right? They are on site, they do factory walks. We ensure that we have Rapid employees actually looking at the manual operation before we say yes to something. From there, they take videos, pictures, dimensions of the floor. They take a list of requirements, and they bring all of those to my team, and specifically the concept design team that reports to me, and we go through a task scoring process. That task scoring process allows us to look at the various complexity points and ensure that this is something that we are very confident that we're going to be able to automate. After we score it, then we make a decision. Is this something that, again, that we know we can do? We can do so in a reasonable amount of time for our customer, and provide our customer with the confidence that once this goes into production, it's going to stay operational. There's not going to be a lot of downtime, and we remove as much risk as possible. And I did forget the build, unfortunately, but what I'll show you with this video is some of the things that we look for. So first and foremost, you can see that the operator is trimming some gates. We would be asking questions like, is that something we need to do? Or is that not part of the process? You also see that as she's processing these parts, and it'll happen here in just a second, she's kind of holding down the foil on this hot stamping machine, right? And that's happening right here. That's another thing that I would point out, that, okay, is that going to be something that we're going to need to deal with as well? So these are all things that my team is looking at. Again, really our goal here is to ensure that we have a full understanding of the requirements and that we're signing up for things that, quite honestly, we're not going to end up not being able to be successful in. And like I said, this is a benefit to the customer as well as Rapid. And quite often, we were telling our customers that we are not comfortable signing up for something because it's in the best interest of both parties. And I think we say no to a lot of tasks, and part of what we're doing during this feasibility assessment is being consultants for our customers, right? Quite often they'll bring us in and say, hey, we really want to automate this task. And we'll take a look at it and we'll say, I'm not sure if that's right for us or for automation, generally speaking, but we noticed the task over here and we really think we can help you out with that task. And so, what I would urge potential customers is to keep an open mind when it comes to looking at automation opportunities, because if your goal is to automate a very specific task, well, then absolutely, let's come in and we'll take a look. And if we can do it, we'll tell you we can do it. And if not, we'll also tell you that. But if your goal is to maybe offset some labor burden, then keep an open mind and allow us to really tell you where we think we will be successful. And that's really it's been very helpful for many of our customers, because like I said, oftentimes what they bring us in to look at doesn't end up being what we ultimately automate, but they still get all the gains of automation. Okay, so after we do the feasibility assessment, we make a decision whether or not to move forward. Assuming we do, the next step in the process is automation design. And the automation design, it starts very, very high level. It starts usually with a couple of engineers in a room on a whiteboard, kind of laying out the work cell, understanding how parts will flow through the work cell, understanding the requirements, maybe at a high level to start. And then from there, we start to bring it into CAD, and we're doing things like reach analysis, cycle time analysis to ensure that we can keep up with throughput. We are looking at grippers and fixtures for the first time and figuring out, okay, how are we going to grasp this part? How are we going to ensure that we can pick up the part repeatably every time? Do we need to include things like vision for inspection purposes or for picking purposes? How are we going to fabricate these fixtures? How many parts are we going to be able to hold in the cell at one time so that runtime stays as high as possible and operators only need to go to the cell, as the least amount of time as possible? So these are all the things that we're doing, and some of the tools that we're using. Obviously, CAD tools. So we do a lot in CAD. We're using very low tech tools like whiteboards and Google Draw is a tool that we're constantly in, just moving blocks around for block diagrams. But then we also start to use some of our more sophisticated tools. We have built a proprietary simulation tool that allows us to basically take ideas and optimize them with the click of a button. And so that's where a lot of our speed gains come from. So typically, automation design will take a lot longer than 2 to 3 days. But these tools allow us to very quickly iterate without the use of physical hardware, right? So the more, and this is something I stress to my team, is the more we can do in sim, the better off we're going to be. Because moving a fixture to optimize, say, a motion path in a simulator is so much easier and less time consuming than it is to unbolt that fixture, move it, test it, and find out, okay, no, that was actually worse than the original place. So we do as much as we can virtually, and it also ends up helping us down the road because during this phase, we are creating a digital twin of what's going to end up being deployed. That digital twin helps during the actual prototyping and testing phase, because if we need to iterate on something, we go back to this digital twin, we iterate there, we finalize the design, and then we go back to hardware. And it also helps in support so that we can see what is that robot doing, and we don't need to be on site to see where we are in a motion path when a certain error occurs, because all of these tools are available to us wherever we are in the US or in the world, quite frankly. So the automation design basically sets the stage for what's to come in the future. After automation design and once we've finalized what that design looks like, there's meetings with the customer. We're showing this to them. We're getting buy-off from them. We start with as low tech as possible, and then once we have agreement on design direction, we'll take it to CAD and simulation. We provide all of this to the customer so that there's no miscommunication and assumptions. We're all on the same page about what we're doing before we go to do physical hardware. But that is the next phase. And that next phase is prototyping and testing. So this is when we take that CAD and we actually create the gripper that we're going to be using. And then what we're doing in our office is getting a good understanding. In this case, you see a gripper that has a bunch of suction cups. This particular gripper has multiple zones where we are picking up various SKUs. We're testing flow rates with our vacuum system. We're testing the motion path with that end of arm tool to ensure that there's nothing there that's going to cause any conflict with collision or reach. We are you can go pretty far in simulation, but you really won't know entirely what the issues might arise until you're doing things on hardware. And so it's really important for us to spend a lot of time, quite frankly, setting this up in-house and ensuring that it's going to really be successful when it hits your floor. In most cases, we are doing as much as we can to simulate the hardware that we're going to be interacting with in production. In some cases, we actually have that hardware. Sometimes we're mocking it up so that we're, we have an accurate representation of pick points and place points and machine nests. And we're basically leaving as little to the on-site deployment as we possibly can. And this is to ensure that we're not disrupting production and we're in and out of your floor as fast as we possibly can. So, I'm in the office today. If you were to look around the office, you can see multiple work cells being worked on, doing testing, ensuring that, we've gone through the program a whole bunch of times before we do our final FAT, which is something that we do internally for every single one of our deploys. They go through a rigorous checklist. FAT, if you're unfamiliar, is a factory acceptance testing, meaning we ensure that every deployment that leaves our floor is up to rapid standards, has gone through a checklist of items to ensure that when we get into production, it's going to be successful. And those are all signed off on. And again, this is in service of ensuring success when we actually get on site. So once we are confident with the solution, we put it on a pallet, we wrap it in saran wrap, we ensure it's not going to break in transit. We put it on a truck and we get ready for the actual on-site deployment. So the on-site deployment, depending on where we are, we're sending engineers on flights to your facilities or in cars if it's local, and we are ensuring that like I said, we're on site for the least amount of time as possible. At this point in time, we've communicated anything that we need from your team to ensure that we are, we have what we need to be successful, right? So we're scheduling the downtime in production. We're ensuring that you have a bank of parts if throughput is something that's important, which in most cases it is, and that this downtime is going to be is not going to impact orders. And we are doing the final integration into the machine. Now, most of this work is really just the connecting our I/O to the machine I/O, because in most cases that's not something we're able to do in our office. And a lot of time is spent just watching production. In this phase, what we're looking for most importantly is the edge cases that we were unable to find in our office, right? So what's typical at this point in time is a very quick, sometimes 4 hours, all of a sudden we're in production, but we may stay on your floor for 2 or 3 days, just watching things, doing little tweaks here and there, and making sure that when we leave, this is, we're leaving and we won't have to come back, right? That is really my goal. And I think that's probably pretty obvious, is that, we want to leave and we only want to go back to install the second robot, right? And so now the other thing to consider is that, many of our customers look at Rapid as an extension of their engineering team. Because this truly is an end-to-end service, right? All the way from finding those projects to the design and the testing and implementation, as well as the support and maintenance that comes after the fact. So, this is usually something that is pretty quick, and then we go on to our support. So after deployment, we have a suite of remote monitoring tools. We do probably about 98% of our support tickets can be handled over the internet without having to bring somebody on site. And so we really pride ourselves in what we've built from a remote monitoring standpoint, and we are often able to identify problems before our customers even see them. We start to see anomalies in certain graphs and data reports and logs, and we say, hey, something may be up here. We also have AI that kind of gives us a heads up when something's not looking right. So if there's any deviance deviation from norm, we are being informed of that by our software, so that we can very quickly start to assess what's going on. Many of our deployments actually have cameras installed so that we can see where that robot is. We can also see it virtually as well with our digital twin. And like I said, we do a vast majority of our on-site our support tickets remotely. Now, in some cases, obviously there is an on-site requirement. We have an excellent field service team that will respond to those tickets and get on site when necessary as quickly as we can. But what's great is that in almost all of the cases, they're not going on site with zero knowledge of what they're going to be looking for. Most of the time, they've figured out what has happened and they're going on site to fix it, and not just necessarily going on site to try and figure out what's going on. So what that means is that when they do go on site, the amount of time that they're on site is very limited. So again, I want to emphasize the fact that all of these processes and these efficiencies are not just efficiencies for Rapid. These are things that benefit the customers as well. Because as much as our customers love our Rapid engineers, the least amount of times they have to see them, the better, right? That just means that things are running smooth and that the deployment was quick and seamless, and so we really try to stay out of your way, and we're able to do that with some of these really amazing tools that our software team has built for us. So yeah, I think that kind of brings us to the end of the journey here. Patrick, I don't know if there's any questions that may have come up, but I will pause there and see if there's anything we want to discuss.
Hey, thanks, Paul. Or sorry, Steve.
Yep, no problem.
This is great. Yeah, we did have a couple questions that came in. So I guess I'm going to paraphrase here a little bit. Can you talk a little bit about how all this makes robotics more accessible? I mean, we've tried cobots before and ran into a ton of complexity.
Yeah, for sure. And so, that's, to me, when I hear that exact phrase from a customer, I think that Rapid is in a really good position to help that customer out, because part of it is that cobots have been designed, and you are, and all the other cobot companies have designed their software to be very easy, but it's still not super easy. So even if you are hiring engineers on your team to take care of this work, either we are coming in and doing all the work that they don't have time to get to, or we are helping them because automation is not super simple. And so so when I mentioned that we're augmenting your engineering team, that's where we're really removing a lot of that complexity. We are coming in and it's end-to-end turnkey automation. So we remove all the complexity. and all the headaches that come with trying to get something automated with robots. We are the experts that you can rely on to make sure that there's not going to be any challenges with the automation.
Another question that came in here is, on a support call, why replace a robot instead of repairing it on site? Is that really faster?
Much faster. So all of our software actually lives in a computer separate from the robot. Really, the robot is just something that we are controlling with our computer. So instead of coming on site and trying to repair joints or motors inside the arm, we swap it out for another robot. We take it back to our shop, and that's where either we'll work with our manufacturing partners to get this replaced, or we'll try and do this all on our time. But we don't need to do that on your floor. There's no benefit to our customers, and so it's something that we very quickly unbolt and bolt a new robot on, and we leave. We will run our software for an hour or so, making sure that there's nothing weird with the new robot. But as opposed to spending who knows how long trying to identify problems with the robot arm, we just swap it out and get our customers back into production.
Cool. And this one just came in, and Rapid. From your guys, Steve, from your perspective, your team, that kind of thing, what's the majority of applications that we're automating today?
Lots of machine tending, lots of pick and place. We've done a lot of work in plastics manufacturing. We have a couple different size robots. So, one of the first things we're looking at during the feasibility assessment phase is the payload and the reach. If what we see is that secondary operations for plastics is a great space for us to work in, but more generally speaking, machine tending is something that really is a great task for a robot, especially when there is characteristics of the task that are ripe for automation, right? If we're in line with other processes that can be, the parts can be fixtured, or if we're dropping off into just a box at the end, maybe picking parts that a Cartesian robot may have dropped onto a conveyor belt that we can rely on the position. Those are really good tasks for us. Simple pick and place tasks, we do a lot of those. I know that's fairly general, but the reason I'm being general is because we're not really stuck to any particular industry. We've done tasks from pharmaceutical fulfillment to metal processing. Like I said, plastics and secondary operations in plastics is a great one for us. But we're not limited to an industry or anything like that. It really comes down to the characteristics of the task. But I think the easy answer here is machine tending and pick and place operations.
So that was the next question. Is there a particular market or industry that we're focused on? So it sounds, obviously we're pretty generic across the board there.
Yeah, no, it really is the task characteristics that are important. I think that certain industries they often have characteristics of tasks that make it better for us, but again, we're not limited to we can't do tasks in certain areas for whatever reason. No, we assess every task individually and ensure that we have the confidence to automate successfully.
Another question came in is, can you give some more examples of how 3D printed grippers speed up deployment?
Yeah, so that's been really helpful. We have a bay of 3D printers here in our office. It helps in a variety of ways. First and foremost being just the ability to do quick prototyping. So we have a couple different types of 3D printers. One that prints fairly low fidelity, but very fast. We use that for kind of that initial concept and ensuring that, okay, yeah, suction cups are in the right spot, or, we're going to be able to go through our motion paths without collisions. Or we're just going to be able to grasp the part the way we intend to. And then we can go to a more robust 3D print, with strength of material that's, very close to, metal and so, no issues there. 3D printed material, while it is very strong, is also very light, which is great when we're trying to push the limits on our payload capacity. And so, but I think that the biggest benefit really is the ability to do quick iterations as well as completely custom designs per deployment. So we're not limited to what some of these robot gripper companies have on their shelves. We really pretty much every single one of our deploy has a gripper that's designed custom for the part that we're interacting with. And that's really only achievable. I mean, it's achievable with machined parts or whatever as well, but for cost-effective gripper design, it's 3D printing has been really beneficial in that area.
And another question came in here. Have you worked, we worked more with small weight pieces or larger components? What's that kind of?
Yeah, so right now we have a 5 kilogram payload robot. We have a 7 kilogram payload robot and a 10 kilogram payload robot. Those are the 3 most common robots that we are deploying at the moment. That being said, Rapid and the software that we've created is, I don't want to say it's robot agnostic, because we don't really look at it that way. We look at, what robots do we want to bring into the fold, and we are not limited to any particular robot and if there is an opportunity that makes sense for us that requires a larger robot, that's something we can look into. So, but right now, I would say that our standard deploys are somewhere between 5 and 10 kilograms.
Yeah. So when it comes to, let's say really small, intricate plastic parts where high accuracy is really important, how well does our solution solve for this?
Yeah, so if depending on the accuracy, we have both a collaborative robot offering and an industrial robot offering. The collaborative robot is very precise, but not nearly as precise as the industrial robot. So we're talking sub-millimeter precision on the industrial robot that is going to be very accurate in almost all cases. And it's not just accuracy, but it's repeatability as well. And so if accuracy is very important for the task to be successful, then we often look at the industrial robot for those tasks.
I know we have a couple of videos on our website too that kind of poke around at that as well. So feel free to check those out. Any other questions? That's the end of the questions that I've gotten so far. If there are additional questions, Steve, can you go to the last screen? There is a QR code there. Feel free to take a shot there if we didn't get to your question, or if you have additional questions. Again, I want to thank everyone for participating. Be sure to look for our next webinar, which will be coming out here the 25th of this month. So I'll be sending out invites as well. Also this afternoon, you'll get a email kind of detailing or give you the link so you can watch this on demand, and please forward it to whomever. And if you do have questions, feel free to reach out to myself or Steve. We're more than happy to help with any types of questions going forward. Again, oh, just got another one here. Can you pick up from a random spot in a bin, for instance?
I mean, it's hard to answer that question without understanding a little bit more about the task, but I would say generally speaking, yes, we have the capability to do unstructured bin picking. And so, again, I'm not going to commit to anything, which I don't think is what's expected here, but I would say we do have the capability to pick from a bin where parts may be in, unknown locations.
Yeah, I think one of those things, this is a great kind of segue to say, for these and other types of tasks, really being able to get our AE or sales engineers on site to be able to take a look at this is really a great way to assess not only these types of tasks, but other types of tasks that you have going on in the manufacturing environment. So again, look for the on-demand viewing of this webinar. We'll also be posting this on our website along with upcoming events that we have going on. And again, feel free with any questions, reach out to myself, Steve, or anyone here at Rapid Robotics. We appreciate you guys taking the time today. Thank you very much.